Sir Donald is in the waiting room, waiting for you to let him in.
Okay. Good night. The pair of you. I don't know where the other students are. Are you hearing me, guys?
Yes, sir. Hear me?
Um, Trishan is typing something. Let me see what she's saying. Oh, but I'm not seeing anybody for let them in. Oh Lord. Clearly they're not using. Clearly they're using their Oh man. Alright, let me claim host. I can't claim host from me here. Oh jeez. Mm-mm. What's your? Oh, I need to get locked out too. The host will let you in soon. Okay, I need to. You are on. The host will let you in soon. Oh my Lord Jesus. Mm. Right, I'm trying to find. I can't find your host, Steve. Alright, so Trishan is waiting. Hmm. Alright, do me a favor. While I try to sort this out, can one of you ask? No, but I'm using my ECC and I'm not getting in, so that won't be the thing.
Sir, can you repeat what you're trying to say?
Um, there, um, the device that I'm using, I cannot. It's not giving the option to. to put in the host key. And I'm logging into the other device that has that functionality. It is locking me out. It's asking me to hold on because the host will let me in. Let me try a third device.
Sir, you can give one of us the host key and we turn over host to you.
No, but you can't. Can you get on? Can you get into it? Can you add the can you claim host? See if you can claim. Go to the participants list and see if you can claim host from there. Can you? All right. So let me give you the host key. Oh my Lord and Father, no sir. Um, 416 482. 416
Mm-hmm.
482.
Okay.
All right, good. I see that you get the host now. Letting those people from it first, please.
In.
You said about in the waiting room?
Yes, sir, they're joining now. Sir, which one of your devices
This
that
is,
must be the host?
the one that has the speaker.
Okay.
All right, thank you, my dearest. Forgive me, Tiana and Donald and Trish. I'm here sitting and waiting, and I said, but who is only the two of them in class? And it's not until I went into WhatsApp I recognize. And then you, Miss Trish, you are sending me this. When we drop it in the group and say, sir, we can't get in. And
Sir,
Donald,
uh,
you're sending
because
what?
sir, I said it because we were the only one online. So I said to you that people are waiting in the waiting room. I'm not sure if you're in there or if you hear me.
Why don't you feed the kittens?
Sir, I'm not doing her nothing.
All right, I apologize, guys. Really, really, really apologize. I'm here sitting waiting, and then Trish, saying, you're not letting me in. I apologize. Right, so Donald, you have a class going on at Mr. Roku right now? I don't see your microphone open, but you can send it in the chat. You can respond to me in the chat.
Sir, he can't hear you because the audio connecting.
Or the audience connecting. All right, cool. I give him 2 more minutes. T, how you do?
I'm fine.
Good, good. All right, so I don't see where Donald is connected to the. Oh yes, he is now connected to the. All right, Donald. So I was asking Papa, you have a class now?
Normally that would be pre-calculus. We actually have just finished factor theorem last week, but I'm not getting through to Mr. Rockwood right now or any of the other class.
Oh, okay. All right. So, all right. So I won't go. All right. Okay. I'll just continue.
Actually, don't do that.
Right.
Mr. Rockwood tomorrow.
Right. Yeah. And it's actually Rookwood.
Oh, sorry about that.
Yeah, man, that's fine. No, man, that's fine. So, based on the conversation that Donald and I will have after he speaks to Mr. Rookwood tomorrow, I may have to rearrange the time, and then also Trishi has an issue in getting home at this time based on what she shared with me earlier. So I will now need to look at some other times for the session. But nonetheless, we are here tonight. Let us see how best we can navigate through this. So welcome to linear algebra, mathematical analysis and linear algebra. I am going to, let me just, how should I put this? Let me just talk to you about the interconnectivity of some of these courses. Now, I'm going to be doing an area with you tonight that two of the students would have gone through this in a previous course. But nonetheless, I'll have to do it because the rest of you have not yet done the course. Or some of you are doing the course now. But it's going to be a prerequisite to the other area, so I have to do it. So I'm going to say to, where's Dana? Dana's not here. Can somebody put something in the group and call her for me, please?
Sir, call who?
Dana Ingram. Dana? You know when we're talking?
Yes, sir, I know who you're talking.
Yeah. See if you can ring her for me, please, and hope she don't drop asleep. All right. So I'm going to go through that with you. And then the second topic I'm going to go through is going to be a topic that you will see again when it says that you move on to the Bachelor's in Finance and Management and doing operations research. That topic is going to come up again. So the two of you already, so two of you would have already gone through this topic I'm about to do, but I have to do it so that others can be on the same page because it's a part of the syllabus. Normally you'll do this course after you do pre-calculus, so I won't have to go through that topic, but it's not a problem. It not being pre-calculus just yet, or not, yeah, having completed pre-calculus, it really doesn't matter. So I'll just jump to that topic. So what I'm saying to you is, when your pre-calculus teachers get to that topic for you, with you, it will be so much easier for you to understand because you will already know how to do the topic. You will already know how to do the topic. All right. So I'm going to go, and then now I'm saying to you, when you move to operations research, the second topic that I'll be doing tonight, you're going to be doing in operations research. So you will know exactly what to do. Hold on a minute, please. All right. Are there any questions so far?
Sir, is there one specific area under the bachelor's program?
I mean, when you say one specific area, I mean one math course?
No, as in like You said it's mathematics and management. That's
Mm-mm.
what you said.
Finance and management.
So that's the only thing that's there for the bachelor's course.
Mm-mm.
So what else is there?
HR, marketing, and the likes, accounting, um, and yeah, and yeah, those.
Okay.
Okay, so I'm trying to share. I had a challenge earlier. I had a challenge earlier in my class trying to get this thing to share. I'm trusting that it does not give me. Mm.
All is well. What exactly are you trying?
Say it again, Donald.
All is well.
Yeah, man. Most things are well. It's just that you know, when you're doing something here, Papa.
Yes, multitasking can be paid.
No, it's not multitasking. No. All right. So what I do is, well, this is going to be the first time I'm interacting with you, but like Tiana and KK and Joanna would have seen how I do my stuff. Now I use what I call a tablet to write on the screen. Now I save the document for you, but the document that I save use ink, and now it is because of the ink there is some interference with the stuff, so it is posing a challenge to open. So it took me quite a while in my calculus class just now to open. So it is posing a little bit of challenge, but never mind. I'm going to see if I can just share it using the Microsoft Word instead. The life of a teacher, the life of online. I love online, you know, because it is just moving with the technology, but sometimes you have these sort of hiccups going. Works this minute, next minute it don't work.
Well, I love online for other reasons.
You can be wrapped up in your bed while you're learning, right?
You said it's not me.
That's right. Got you.
A nice book. Yes.
Got you.
Some coffee.
All right. Are you seeing the screen?
Yeah, matrix is singular, matrices is plural.
All right, good. So we're going to be looking at a topic called Kramers. And I know two students in the class supposed to jump in for and say, yeah, I know how to do Kramers, and maybe both of them is saying, but I don't remember how to do it, or maybe one saying, I don't remember both of them, you know, but yeah.
I do not remember how to do
TT,
I have a light about that, so I don't remember how to do it.
TT, you remember how to do it?
No.
Tiana, TT, you don't remember how to do it?
Oh, so wasn't that from like 2020?
I don't. Tiana, let me ask you a question. Do you forget how to ride a bicycle when you learn how to ride a bicycle?
I don't even know how to ride a bicycle.
I love it. Oh, man. All right, never mind. All right, so I guess we are all on the same page. Not quite. When I go through, they will get it. All right, so let us just have a little conversation about the naming of matrices. So in a matrix, we have something that we call rows, and those are the things that are horizontal. Horizontal means they move from left to right. And then we have those that we call columns, and these are vertical, and vertical runs from top to bottom, right? So in a matrix, we have rows and columns. Rows and columns. Rows are those that are horizontal, running from left to right, and the columns are those that are vertical, running from top to bottom. And matrix is singular, and plural would be matrices. Matrices is plural, matrix is singular. So once I'm speaking about more than one of them, it will be matrices. But if I'm only referring to one, it will be a matrix.
Sir, can you go back up a second, please?
And I see this is a problem I have. You notice you're not seeing any of my, you see all of those blank spaces should be my formulas, but it's not coming up. Because right here, I want to recognize it because I have something right here. Is a supposed to be representing something else. Go ahead, Joe. What you saying you want me to present to you?
Yeah, I was asking you to go back up because you were scrolling down.
Okay. I'll have to stop sharing again and see if I can get back that stuff so that I can show my ink. I don't know what is happening tonight. Other nights it shows beautifully. This night it wants to give me some problem. Kendra, you all right? KK? KK, look like she's gone under the sheets and gone sleep.
Sir, I'm here. Andra?
She,
press on mute.
it doesn't take no while to press on mute. I doze off because she's tired.
No, sir. It's just that I never turned my mic on ever, so I was expecting you to call my name.
Oh, goodness. I don't know why teacher troubling me tonight. Lord. Not necessarily the identity that we're looking at. Trish. And then, all right, let me try this one more time. Father, I pray that this thing will just work. All right, so. Hold on, guys. Give me half a second. I'm gonna go to a different device because it's not working out. Come in. Are you seeing my screen now, guys?
Yes, sir.
No, good.
Sir Dana is asking to be let in.
She got, let her in, man. She's there now. There now? Oh, she's okay. She's there. All right. So all of my pickings are here now. 1, 2, 3, 4, 5, 6, and that person. I saw him in the group today, so it favors set him not doing the course again. It's not time about switching this, switching the axis. It's just that my what I use. Well, you all that I've taught in a previous course will know what it is that I use. So that's what was posing the problem. So I had to PDF the document so that the document could come as is. The Microsoft Word won't work. It's not compatible. All right, so it's the same thing up top, except now that you are now seeing my matrices. So what kind of matrix is this one? A11, A21 is what kind of matrix you call this?
1 by 1 matrix.
This is a 1 by 1?
Sir, I don't know.
What say the rest of you? What kind of matrix is this? Talk to me now.
Isn't that just a column?
Let us look at the nomenclature again. Or look, rows. How do we name the matrices? Rows, then columns. How many rows are you seeing there?
Sir, 1.
How many rows are you seeing?
2, sir.
2 rows.
2 rows and how many columns?
1, sir.
So this is a
2 by 1.
A 2 by 1 matrix, right? So that's a 2 by 1 matrix. Let us look at this other one here. How do we see? How do we read this one?
1 by 2.
A 1 by 2. And how do we read this one?
2 by 2 square matrix.
2 by 2.
So Donald, I hear you say 2 by 2 square matrix. All right, let me hear what you say for this one, Donald. What is this one, Donald?
3 by 3 square matrix.
Why do you call it? Why did you say 2 by 2 square matrix and 3 by 3 square matrix? I never said that for 1 and 2, Donald.
Well, I didn't say. Well, actually said. Isn't that just a?
Sorry, you're gone. You're gone. You're gone. Not hearing you.
Oh, I'm sorry. You just try and recall. Number 1 and 2 inform an based off on fact.
No, sorry, Donald. Sorry, Papa. You're in and out. I don't hear what to say. Say it again.
Can you hear me fully now?
Hear it clearly now.
Okay. Rows and columns must be equal for them. Isn't that correct?
Anybody hear him say?
No, sir, he's low.
You're in and out, Donald. Can you just put? You really I can relate it to trumpetry, you know. Sure. Type it and we can see. Trisha, are you here?
Sir, you can't hear me?
Yes, I hear you now, man. Yes, dear, I hear you now.
Oh, what did I type? You didn't type?
Nothing type at all. All right, talk now because you came over clearly a while ago. Say it again. Don't move. Stay right there, so.
the number, row number, and the column number must be equal for them to
Very good. All right, don't move. Stay right there. So anytime you're talking, just catch back that position there, because you can move up clearly. Very nice. So you are correct. So the reason he didn't say anything for 1 and 2 is because they are rectangular matrices. 1 and 2 are rectangular matrices because the number of rows, the row is not equal to the column number. But for 3 and 4, he made it clear that these are 2 by 2 square it's a 2 by 2 square matrix and a 3 by 3 square matrix. Why? Well, because the number of rows equal the number of columns. Very important. So this one, you see this one look like a rectangle, and this one look like a rectangle, but this one is a square because the number of rows equal the number of columns for both 3 and 4. Very important piece of information. All right. Now, for linear algebra, we'll be working with a 2 by 2 matrix. Sorry, a 2 by 1 matrix. You may or may not work. Yes, you will work with a 1 by 2. You're going to be working with a 2 by 2. You can also be working with a 3 by 3. So this. Go ahead.
Sorry to cut you, sir. So what's the name for the second and the third one? The fourth and the third one.
It's a 2 by 2 square matrix and a 3 by 3 square matrix.
Okay, thank you.
So all these matrices, the different types are going to be used in linear algebra. All right. So for this course, we're going to concern with a 3 by 3 mainly, but at some point in time we're going to be looking at the others. Now, notice we call the rows first, followed by the columns. We call the rows first, followed by the columns. Now, let me go here and ask you, what do you think I mean by A11, A12, A13, A21, A22, A23, A31, A32, A33?
Sir, you can like repeat that whole thing but slower.
You're simply telling us to position the specific item in the matrix based off the system that you're using. For example, the first, can you hear me fully?
Yes, Papa, continue, I'm hearing you clearly.
Okay, it's just basically a system that allows you to tell the position, tell which item we are talking about in a matrix, whereby the first digit represents the row, the second digit represents the column.
Excellent, Donald. Very good. Right. So those things that you're talking about, Donald, are actually called elements or entry. So in each matrix, the element or entry has a fixed position. A11, A12, A13, A21, A22, A23, A31, A32, A33, as Donald says, is telling me the position, the row, and the column for which they are placed. So if I speak of A23, A23 is telling me that I'm in the second row and the third column. So each element has a particular position. Just like when you go to the dentist and you say the number 15 tooth, they know exactly which of them we're talking about. They know exactly which of them they are talking about because each tooth has a particular position in your mouth. So when you speak about number 1, you're talking about one of those in the back of the mouth. And it comes around, so they know exactly which one. So if the dentist is saying to her assistant or his assistant, I need to investigate number 8, top 8 or bottom 8. They know exactly which of the tools they are referring to. When I speak of A23, I know which element or which entry of the matrix that I'm referring to. Very, very important. Very, 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 very important. All right. Now, so A11 indicates that the element is in the first row and the first column and so on and so forth. Now, what I want you to remember or to know is that we're going to be speaking of the ith row and the jth column. We're going to be speaking of the ith row and the jth column. Sir, yeah man, the ith row and the jth column. When we're referring to a 3x3 matrix using Kramer's. Look at what is happening. It is going to be -1 raised to the I plus j, the ith row and the jth column. So the values here, the first one is representing a row, the second one is representing the column. So I'm going to raise -1 to the ith row and the jth column. So look at what happens. 1 plus 1 is 2. When I raise a negative number to an even power, what result do I get all the time?
Negative.
A negative number raised to an even power, what do I get?
A positive number.
Positive.
A positive number. And when I raise a negative number to an odd power, what do I get?
Negative.
A negative number. All right, so watch me. So this term is going to be positive, but this term is going to be negative. So how you know? 1 plus 2 is 3. 3 is odd. This one is going to be 4, so this is positive. So here we have positive, then a negative, then a positive. Here, 2 plus 1 is 3, negative. 2 plus 3 is 4, positive. 2 plus 3 is 5, negative. 3 plus 1 is 4, positive. 3 plus 2 is 5, negative. 3 plus 3 is 6, positive. So what we're having here is a positive 1, a negative 1, a positive 1, a negative 1, a positive 1, a negative 1, positive 1, a negative 1, positive 1. So even powers result in a positive, while the odd powers result in a negative. And that is when you give birth to the array of signs. Plus, minus, plus, minus, plus, minus, plus. Plus, minus, plus, minus, plus, minus, plus. Plus, minus, plus, minus, plus, minus, plus. All right? So you recognize that the signs alternate. And at no point in time do you have, when you're going to the columns or to the rows, do you have two same signs. All right? You can't go along the diagonal. You're not allowed to go along the diagonal. You can go along any row or any column. So it is an important ingredient in the application of Kramer's rule. Let me pause here. Are you following so far?
Here, I just need to take a picture of the one above if you can go, please. So not so far, but you can go back down now.
Are you understanding so far?
Okay.
Data boom? All right?
Earlier in the chat.
Oh, thank you. You know, for those of you who have not taught in a long while, you have to just remind teacher here, say, sir, check the chat. One of these days I'm going to group and check the chat every time, you know. But for now, yes, Trish, I just see that you even send message in chat too. Yeah, man, this is an advanced version from high school. Hey, a big school there, Trish. University there, man. Big school mathematics. So that's why students when you're finished with your program, you should be able to go into the schools and teach. If it is that you want to become a teacher, you should be able to go to the school. As a matter of fact, I have a student, Dale. Oh my goodness, long time I don't see him. Dale did his associate degree, didn't even do the bachelor's yet. Did his associate degree, completed his associate degree in business administration. And my good little student was able to do an advanced teaching diploma at Michael. And then he went to a school and was teaching. And because he has the associate degree, he was teaching up to Cape MLB and them something there. So Joe, leave me alone. All right, let's go. So just remember the array of signs. Plus, minus, plus, minus, plus, minus, plus. Very important. The array of signs are very important to solve a question using Kramer's. Very important to solve a question using Kramer's. Plus, minus, plus, minus, plus, minus, plus. Very important. All right? Let's go. Let us look at this example. And importantly, students, you're not following what I'm doing. It's important for you to stop me to say, sir, can you redo for me? And those of you who are now doing pre-calculus, that will be 1, 2, 3 of you. When you get to pre-calculus, when you get to Kramer's in pre-calculus, you will be ahead of the class. I can tell you for your pre-calculus exam, you'll get a full question for 20 marks on Kramer's. When I'm finished with Kramer's with you tonight, already you can answer any question on Kramer's on the past papers. So I say this to say to you that none of you should get less than an A for pre-calculus, because I am teaching a topic, a whole topic that you'll get in the course. And I can tell you, you'll get a full mark, full question on this topic in the exam. All right? Let's go. 1 minute, please.
So I think you drop out.
No, man, I'm here, man. I just asked for 2 seconds a while ago. All right.
Okay.
So I'm back with you now. So, yeah, man. So I expect you guys to do very well. Those of you who are in pre-calculus know, and that's why I give you pre-calculus, because I think it will help you for this course. And therefore I'm expecting you to get excellent grades. All right. So I want you to look at that example. You have 3 equations in 3 unknowns. 3 equations in 3 unknowns. What it means there is you are going to use these equations, these linear equations, to create your 3x3 matrix. And we're taking it in stepwise. So you're going to write the system of linear equations in a matrix form. You're going to write the system of linear equations. You're writing the system of linear equations in a matrix form. Please note that we are looking at the coefficients of the variables. And the coefficient means number in front of the variable. So in equation 1, the coefficient of x is the number in front of x, which is 2. The coefficient of y is the number in front of y, which is 3. The coefficient of z is the number in front of z, which is 4. Right? So therefore, this is how I end up with my first row. 2 from here. I'm not touching the variables. I'm only looking at the coefficients, the number in front of. So I'm going to have 2, 3, 4. See it right here, so? 2, 3, 4. Down here there's a 1 right there. When I have x written alone, just imagine that there's a 1 in front of it. X is not equals to 1. When x stands alone, it means that the coefficient of x is 1. So I'm going to have 1, negative 2, and positive 1. See here? 1, negative 2, and 1. Similarly, I'll have 1, negative 1, negative 1. See here? 1, negative 1, negative 1. And then because my equations are arranged in columns where I have all my x's first, then all my y's after, then all my z's after, I'm going to have it as x, then y, then z. And I will then have my equal sign, because this equal sign will govern the first, second, and the third rows. And then it's going to be equals to 12, negative 2, negative 2, 12, negative 2, negative 2. So this is how we write the system of linear equations in matrix form. We look at the coefficients, then the equations are in the form x, y, and z. So I'm going to write the column x, y, z. Now let me just show you a quick thing, how I can move back from here to my system of linear equations. When I'm multiplying, this is how I go. 2 times x is 2x plus this 3 is going to multiply the y to give me 3y. So there's 3y there. And then this 4 is going to multiply by the z to give me 4z. Similarly, moving to the second row. 1 times x is x. Negative 2 times y is negative 2y. And 1 times z is going to be z. Again, 1 times x is x. Negative 1 times y is negative y. And negative 1 times a negative z is going to be a positive z. Sorry, negative 1 times this z is going to be negative z. And of course, it's equal to my 2, my 12, my negative 2, and my negative 2. So just remember, when you're writing your system of linear equations into the matrix form, you're taking the coefficients of the variables alone and drop into the matrix. Then you're going to write the variables, one sitting on top of the other, x, y, z. If they give you as a, b, c, you're going to write a, then b, then c. If they give you as p, q, r, you can write p, then q, then r. Right? And of course, that is going to be equals to whatever your sum, your linear equations equal to, and you're going to stack them on top of each other. So the first equation is 12, that go on top. The second equation is negative 2, that go next. The third equation is negative 2, that goes next. All right? Any questions?
coming too.
All right, it's coming. Good. What about the others? Are you okay, Donald? Dana? Trish? Hello. Trish, you can't go sleep on me yet, you know.
I'm good, sir.
All right, thanks, Donald.
Yes,
Trish.
sir.
All right, nice, Dana. Trish, you gonna sleep? You know, say Trish gonna sleep, do you know? Oh, Jesus, help her, Lord. KK, you all right?
Yes, sir, I'm fine.
Nice. And TT, all right, mommy?
Yes, sir.
Nice. And Joe said that she's coming. Trish gonna sleep, you know? Lord, help her. Then now, what is going to be very important in order to work this question? You see, Kramer is so
Sleep.
so you know answer me. Sure. All right, let's go.
Sir,
So,
what is answer?
oh, me never hear your honey bunches. I threw you this so far. That's why it take long for come. All right, let's go. So what is happening now is we now need to apply the array of signs. We now need to apply the array of signs. Sir, the array of signs, yeah. The same something we evaluate with the ith row and the jth column. Remember that from earlier? And we got the plus minus plus minus plus minus plus. See it here? -1 raised to the ith plus jth column of the matrix will give me plus minus plus minus plus minus plus minus plus. This here now will be attached to my matrix. So you see the 2, I'm going to have a plus sign above it. The 3, we have a minus sign. So where the minus sign come from? See here? The array of signs. So watch me. I have my plus, minus plus, minus plus, minus plus, minus plus. So the array of signs are being attached to my 3 by 3 square matrix. You notice I don't touch my XYZ and I don't touch my -12, sorry, my 12, -2, -2. Look at that for 2 seconds. And tell me if you see that.
Well, I'm good.
All right. So tell me that you see the plus minus plus minus plus minus plus attached to the 3 by 3 square matrix. See that?
Yes, sir.
All right, somebody dropped off. Who was that? Tiana is here, Joe is here. Oh, Keandra gone. I know she was having some internet challenges. All right, so look at the next step now. I'm calculating the overall determinant. I'm calculating the overall determinant. And I want you to watch this. I want you to watch this. Not difficult, you know. I promise you when I say it's not difficult. I promise you. So you notice I colorized my first row. I put different colors because I want to show you what is happening. I'm going to be using my first rows. I cannot use my diagonals. I can use any row. I can use any column. I cannot use the diagonals. I'm allowed to use any row. I can use any column, but I cannot use my diagonals. Watch me now. What I normally say to students is, when you're doing a question on Kramer's, write your matrix in pen. Write this 3 by 3 matrix in pen. And always have a pencil near you. Because you see this 2 is going to be my cofactor. So you know that I have my 2 as my cofactor. I put it right in front of this right here. So the 2 is my cofactor. I put it right out here. So, and then any row or any column that 2 appears in, I'm taking out. Watch me. I'm striking out all of this. I'm striking out all of that. What I'm left with is a 2 by 2 square matrix. Watch it. -2, 1, 1, 1. See here? -2, 1, 1, -1, -1. I'm left with this 2 by 2 square matrix here. Notice that the array of signs do not affect the 2 by 2 matrix. The array of signs only affect my cofactor. All right? Then now, the next term, I finish with the 2, you know. The array of signs only affect my cofactor. So you know that this up here says a -3 is a negative sign. That's why it wasn't going on. See the ink right up here, so let me see. Yeah, man, see the ink right up here, so. I don't know, can you see a dot over the 3 right here? That is the ink that was preventing the thing from opening up. I just see it a while ago. I was wondering where it was. I never erased this ink properly. Right? So what is happening here is this 3, based on my cofactor, is going to be negative. It's going to be negative. So that's why I have a -3 right here.
So remember to check the chat.
Oh, thank you, hon. We can see who are saying something to me. Sir, I don't understand that. You know, okay, what you not understanding, honey bunches, sir, what to use a T7 reverse 7. Okay. Trish, what you not seeing? All right. Is she writing? All right. Let me go again. Do you understand how I arrived at my 3 by 3 square matrix?
In general, or just
What's
are you
your-
asking someone?
No one on there. No man. Trisha loan to auto.
Please.
No, Trisha loan to auto. Trisha said everything. Ah, let's go. Quickly. Don't wait until I reach far, then I can say don't understand anything. Let me know from beforehand, please. Let's.
Yes, don't be back.
everything. It was just done at the bottom part, you know. I learned the ones up at the top before.
Oh, okay, got you. Because I was a little worried. I was a little worried. All right, good. All right. So just very quickly again, when I have my system of linear equations, I'm using my coefficients to generate my 3 by 3 matrix. My variables are x, y, and z, so I'm going to write that in a column matrix. And my result of the matrices will also be written in a column matrix. I will have to apply the array of signs, my plus, minus, plus, minus, plus, minus, plus, to the existing 3 by 3 square matrix. So atop each of the elements in the matrix, I'm going to apply my array of signs here, plus, minus, plus, minus, plus, minus, plus, minus, plus. And then now, having set that up, I'm going to now calculate the overall determinant. And in calculating the overall determinant, this is what I'm going to be doing. I'm going to be using my array of signs to select my cofactors. So this positive 2 is going to be my cofactor, the first one, because I'm using the first row. See there? It says using the first row. So I'm using the first row. So in using the first row, I'm going to have this 2. But anywhere the row, the element or the entry comes from, I'm taking out that column and that row. So watch me. So I'm crossing out the 2, this is the first column, sorry, and I'm crossing out the first row. Remember, this is in the A11 position. See there, the A11 position. So everything in the first row, see, A12, A13, and everything in the first column, see, this end with 1, this end with 1, this end with 1. This is going to be taken out, and all I'm going to be left with is A22, A23, A32, A33. See here? I am removing this row, this column, and I'm removing that row. I'm going to be left with -2, 1, -1, and -1. See it right in here, so? And I was saying to you, the array of signs only affect the cofactor and not the entries or the elements. So I won't have this 2 to be a positive 2 and this to be a -1. No, because it only affects the cofactor, not the 2 by 2 matrix. Remember that. Now that I finish with this, and because I can't go here, so, and then jump somewhere else. It's either I'm going to go to the rows or go to the columns. And I often say to students when I'm teaching this topic, let us just focus on going to the rows first until we get a little bit more mature in doing Kramers, and then we can start mix it up and go to different columns or different other rows. So let us just stick to one method first so that we understand it, and then we can do some explorations. All right? Watch me now. I'm using this other cofactor, my third piece, and I have a -3. So my -3 is my cofactor. Look at what happens. I'm taking out this column and I'm taking out this row. So all that is going to be left to be this 1, this 1, this 1, this -1. See here? 1, 1, 1, -1.
Sir?
Yes, please.
Sir, if you're writing on the screen, I'm not seeing anything.
I'm not writing on the screen.
Okay.
All right?
I'm not seeing your mouse moving either.
Let's see. It is. So what I'm saying to you is, all right, so this thing don't work so well. That's a problem now. I'm trying to annotate and it's not. All right, so let me see if I can annotate this way. All right, so I'm taking out this column. Are you seeing that?
Yes, sir.
I'm taking out that row. So what I'm going to be left with is -2, 1, -1, 1.
So that's what I was saying in the chat, and the way how I learned how to do it. The back way 7, the T, and the number 7.
Oh, well, the way we it sound back way for true, but anyhow, yeah. And then when I'm doing the 3 now, it's going to be all of that and all of that. So yeah, so the back way 7, the T, and the 7. Yeah, that's what to say now. So I'm going to have the 1, 1, 1, -1. See here? 1, 1, 1, -1. Trish, you with the teacher now, mommy?
Of course, sir.
All right. Same here, some friend. Good. And then we have that. Remember now, always remember, cannot overemphasize Donald, cannot overemphasize Dana, that the array of signs only affect the cofactor. Only affect the cofactor. All right? And then now, when I reach the 4, all of this piece, oopsie daisy, that goes, this goes. So all I'm with now is 1, -2, 1, -1. See here? 1, -2, 1, -1. And this here is technically how it is that I'm going to be solving my system of linear equations by using determinants. So I have a 3 by 3 square matrix. It is going to be reduced into 3 2 by 2 matrices. And now, based on the question that Trish asked, sir, this is the big school something. Yeah, but now we're going to get to the little school something now, Trish. We're going to go to the little school something now. So let me give you my notation. My notation says, please note that the array of signs only affect the cofactors and not the newly formed 2 by 2 matrices. They will not touch the matrices. They will not touch it. Only the cofactors that the array of signs will affect. All right. Now I'm going to ask you to recall something for me. When you're going to little school, to calculate the determinant of a 2 by 2 matrix, for example, a 2 by 2 square matrix, for example, A, B, C, D, you're going to take the leading diagonal. You're taking the leading diagonal. You're taking the leading diagonal. The leading diagonal is that. You're taking the leading diagonal. You're taking the leading diagonal. And what it is that you're doing is to subtract it from the other diagonal. You're taking the leading diagonal. A times D is AD, right here, so. Minus the other diagonal. So the leading diagonal minus the other diagonal. All right? So if we were to look at that, look at what we're going to have now. All of this piece here, so work with me. All of this is now right here, so. All right? So all of this piece right here, I'm now writing it down here, so we can go through this part a little bit more. So this 2 is this 2 here. This 2 is this 2 right here. So it's the leading diagonal. This negative 2 times negative 1. See here, so negative 2 times negative 1 minus. You always subtract. There's always a minus sign in, let me just highlight that. There's always a minus sign in the middle. Always. Every time there's a minus sign in the middle. So what you're going to have is minus, see here, 1 times negative 1, see here, 1 times negative 1. Then this 3 is this 3 right here, so 1 times negative 1, see here, 1 times negative 1, minus 1 times 1, see here, minus 1 times 1, plus 4 right in here, so times 1 times negative 1, see here, 1 times negative 1, minus, see here, so now, negative 2 times 1, see here, negative 2 times 1. So this line is a direct calculation from, or transposition from the 2 by 2 matrix, square matrices. From the 2 by 2 square matrices. Look at what happens next. I'm going to do my algebraic calculation. Negative 2 times negative 1 is positive 2. Negative 1 times negative 1 is a positive 1. So how I'm reducing it nicely. This negative 3 is this negative 3. And 1 times negative 1 is negative 1. And negative 1 times 1 is negative 1. Right here. This positive 4 is this positive 4 here. And 1 times negative 1 is negative 1. And negative 2 times a negative 1 is a positive 2. And positive 2 times 1 is a positive 2. See it right here, so? And then 2 plus 1 is 3. So this becomes now 2 times 3. And this negative 3 is this negative 3. And minus 1 times minus 1 is minus 2. Rubbishness. Minus 1 plus a negative 1 is negative 2. This positive 4 is this 4. And minus 1 plus 2 is going to be a negative 1. A positive 1, sorry. And 2 times 3 is 6. Negative 3 times a negative 2 is a positive 6. And 4 times 1 is 4. 6 plus 6 is 12. Plus 4 is 16. So the overall determinant is going to be equal to 16. The overall determinant is going to be equal to 16. I know that was a whole lot. I'm going to give you 3 minutes, 2 minutes. Giving you 2 minutes to go through. 2 minutes to go through. Just to look at it and to field any questions you have. Because I'm going to give you a piece of it to work out for me in class, and they will call it a day or a night. So 2 minutes. When I finish it in 2 minutes, you let me know. Don't go sleep on me, you know, when you're supposed to look through, we're looking through the stuff. Any questions so far, guys?
Not from me, sir.
It's okay?
Yes, sir.
All right. This is what I want to do in 5 minutes for me. I want you to do this in 5 minutes for me. Look at what is happening here. So that is how I'm going to calculate the overall determinant. It says calculating the overall determinant. That's how I calculate the overall determinant. Now I'm going to calculate the determinant of x. See here, calculating the determinant of x. I need to show you what I'm doing to calculate the determinant of x because I want you to finish the question for me. So we're going to do that part. Calculating the determinant of x. Look at what happens. This here, this here is my original question. I use the original question to calculate the overall determinant. You notice the O and the O, the original question with the overall determinant. When I'm calculating the determinant of x, look at what happens. When I'm calculating the determinant of x, do you agree that this column is my x column?
Where is it? The first column, the x column?
Right. And do you agree that this column is my y column, the second column is my y column?
Yes, sir.
And the third column is my z column, all right?
Yes, sir.
So what I'm going to do is I'm going to substitute what the linear equations were equal to into the x position. So what I'm going to do is put this 12 into this column, this 12, -2, -2. I'm going to replace my first column. See it here? Okay. So I'm replacing this column, 12, -2, -2, into this position. You see I put it in red? The 3, 4, -2, 1, -1, 1 remains the same. All of these remain the same.
So D becomes A.
Right, right. So what I've done, and you see I still have my plus minus plus.
Sure, cut out.
Two matrices is correct, and then I want you to finish the calculation from here for me. I give you 5 minutes.
Sorry, you kind of cut out just now. So,
All right, what I'm saying to you is Thanks for the information. What I'm saying to you is, now that you have the other matrix to calculate the determinant of x, I want you to, I have done for you, I've taken out the cofactor because I'm going from the first row again. I'm using the first row. So I have done this piece. Check to see if I am correct using the first row. And then I want you to continue with the question, continue the calculation of the question for me. By finding the determinant of this and multiplying by the 12, finding the determinant of this 2 by 2 square matrix and multiply by -3, find the determinant of this 2 by square matrix and then multiply by 4 and then evaluate the answer for me. So I want to see you do this question based on what it is that I would have done up top. If you want me to, I can give you some time to write this question off, and then I can project this piece here so you can see, how the calculation is done. So hurry up and do this for me, please, so that I can double check in with you. Quick and fast. You're math and finance students, so you're far better than the rest of the math students in the college. So come, quick and fast. Hey guys, finished?
Sir, I'm doing the second one now.
When you say second one, you mean the second what?
So as in like I'm doing the Y column now.
Oh, so you finished the X already. That's what you're saying. Okay, good. What is for your answer?
Or 60.
60? Tell me what you got.
I'm coming.
I didn't get 60. I got 16.
Oh, sir, I put 0 instead of 2 plus 2.
All right. All right. What I'll do is, I'm going to send. Okay. Yes, Dana. Very good, Dana. I said that, Dana. I said that. All right. What I'm going to do, I'm going to end here, but I'm going to send you this thing in a few. Give me a few minutes, and then I'm going to send it to you so you can look through for me, and then I'm going to send you one to do for homework. All right. That's okay. Hello, somebody.
Sir, you're not hearing me. I said, okay.
Oh, okay.
Fine.
All right. Good. Good. All right then. No problem. Look later. Take care.